Podmore is a materials engineer at luxury automotive, motorsports and technology company McLaren. Yeah, the Formula One people. And there she leads material science research and development on their products. Ella is also an avid STEM ambassador, dedicated to bringing more women, more diversity, and more youth into design and engineering careers. In 2020, she won the Institution of Engineering and Technology's Young Women Engineer of the Award, and in 2022, she was awarded an MBE for services to STEM education. Have you always had a sense of who you are, what you want, and what it is that you enjoy doing?
Well, if we trace back to why I originally got into engineering, I basically I love science at school, but I wanted to make a difference. I wanted to give something back, contribute to industry, make something better. And I was really fortunate enough to understand that that's kind of what an engineer does at a young age. So I was like, right, I want to be an engineer. Now, how can I tailor this to what I like? And chemistry, learning about all molecules and how everything reacts, that was a big thing for me. So going down that route, I found myself in something called materials engineering, which we'll get into in a little bit. But I grew up watching cars on TV, loved the supercar element, loved the fact that they can be beautiful, fast, and have this exciting industry. And I applied for McLaren, and this is where I've ended up. But since then, I've done a lot of work with STEM and noticed the importance of why people and students really need to understand what's out there in terms of science, in terms of technology, mathematics, engineering.
I want to interrupt you there. I'm having a hard time with it just being called STEM, because as somebody who cannot add numbers together, numbers make no sense to. As an artist, should it not be STEAM, as it has become known in some places? Some people are starting to put the A in there. Or do you see STEM and art very separately?
No, I don't. And it's a really good point. I'm glad you brought it up. So STEAM effectively is including the arts in there. And what is important for us to realize is, even though I do a lot of work with STEM, and that's kind of the scientific subjects, what we need to realize as a company is that McLaren is a STEAM company. We are governed by design. When designers are first putting pen to paper and they're coming up with themes of what they're wanting these cars to look like, we have to tailor the laws of physics to that. So the creative element and the art element is hugely important, as it is to most car manufacturers or even tech companies today. So STEAM is really, really important. I studied STEM, so I talk a lot about the science and stuff, but gosh, do I realize it should be STEAM.
How fast can a McLaren actually go?
Well, our top speed kind of goes around 220, 230 miles per hour. And of course, that's kind of our track focused cars. And then we have some other models that are sort of less track focused, more everyday cars. I say everyday, you probably wouldn't take these to the supermarket, but we're talking probably around 200 miles per hour top speed on average.
When you are putting these cars together, what is the biggest obstacle? Is it weight, or is it wind resistance, or aerodynamics? Because I'm assuming for the McLaren racing, it's the idea is to keep increasing speed. Is that correct?
Yeah, absolutely. So I work on the automotive side of the company. So we've got the Formula One cars that you see going around Grand Prix, etc. I work on the supercars. So there's what we see on the roads, on the tracks, GT races, things like that. And of course, our main objective is to be some of the fastest supercars in the world. And when we talk about speed, we talk about weight. So you hit it on the head there, Oliver. Like, one of our biggest criterias and challenges when we're bringing out a new project is to make sure that it is light enough for us to get the power output that we need. And of course, being a materials focused person, that means I've got to look at what type of materials we're using, how heavy are they. We got to go right down to a microscopic level to see where we can make these weight savings. But lightweighting is definitely the crucial one.
Okay.
If you think about us bringing in an additional weight, but we still want to achieve these top speeds and have this customer experience, I have to make sure that extra weight that we're bringing in is going to have to be taken out elsewhere on the car. And this is by doing clever things with design. So you'll have some designs that have like big holes in, for instance, in our seats. We don't have supported material everywhere. Sometimes we have holes in our seats, and that's purely for a lightweight reason. So we're having to get clever with the type of materials that we use, how they're manufactured, and what the finalized design of them look like.
When you were small and you realized that you were interested in how things work, were you more interested in taking things apart or putting them together?
Ooh,
So building or understanding?
that's a really good question. I would say actually putting them back together. Now, the inquisitive side, so when I was really young and I wanted to know why things worked, my dad would be the one taking things apart, and I'll be like, why is that there? Why is that looking like that? Why have these things got to, I was the why girl. But then my interest kind of was when things were being put together. And I think that's kind of when you start to understand what an engineer does and the different sort of pathways that you can take in this space, putting things together suits me a lot more now that I'm working on a car which is being assembled. I'm not sort of root cause analyzing something. I'm sort of being right, how can we improve this? Let's put this on a new project. But yeah, that's a really good question. And that inquisitive mind when you're young is really important. So don't take apart the toaster, but take apart a few things that you can get your hand on. Start to think why things are put together the way they are.
We hear a lot about carbon these days, and normally in a negative sense, that there's too much of it in the air, and that we need to stop burning carbon. We need to start pulling it out of the air. And so, what is the future of sustainability then in materials engineering?
Good question. So there are two sort of main elements of this in the car industry. So I would say sustainability push for electric cars. So you would have seen all the battery operated cars maybe on the news. These are going to gain in popularity because we just simply have to. In order for us to protect this planet and move the automotive industry forward, we're going to have to focus on electric power rather than this combustion engine, which is producing these emissions. However, there's a lot that we can do in the background to help electrification, we call it, but also other things like the materials, for instance. So the materials that I choose to put onto different cars, we can start to make sensible, sustainable decisions on where these materials are coming from, but also what happens to the material. So maybe the car isn't used for its full life cycle. Where does this material end up? So this planning and recyclability of each of the materials that we're now putting on our cars is a huge part of the process behind the sustainability push. And what we all need to consider is not as simple as just capturing the emissions that we produce. It's actually thinking about how far our parts are traveling, for instance.
What is the future of driving going to look like? Do you think that we're looking at a scenario of driverless cars?
You've touched upon it there with driverless cars. Now, this is a term associated with autonomous technology, and I get a lot of the questions about that. Being in the performance car market, I work in an industry where people love to drive and customers want to have the best experience with these cars. So I get a lot of the questions being like, is there a future for this? Are people still going to want to drive in 50 years? Which is what I say.
Well, there's two reasons that you drive. There's one that's for pleasure and the other one is for practicality. So as to get from A to B, that might be driverless cars, but for pleasure, that might be, a totally, the market might split in two entirely.
Exactly.
We were promised flying cars by now. Do you think that is ever going to be a possibility or a reality?
Personally, I do, actually. Personally, I do. I think what we have got to realise is what limits these evolutions in autonomous vehicles or automotive industry, what limits it is the infrastructure. I do believe we'll be at a situation where we can utilise the vertical space and start flying cars about the place. I can't wait. That'll be exciting. But we've got to consider the additional things behind it. And that's what we'll go on to talk about in the challenge, especially. Think of the infrastructure, where you're going to find these things, how you're going to sustain these kind of flying crafts as well.
In the course of less than 100 years, I think it was something like 60 years, we went from the idea of flying being in your head to being on the moon. And it was without the Wright brothers, there wouldn't have been the airplanes and the industrial machine of World War II, which led to the breakthroughs of the NASA space program, which got us to the moon. And that's all about engineering. That's all about what materials you can use. Is there anything that you're working on now, any of the materials that could be applied to space travel?
Definitely. The beauty of studying materials or being involved in the kind of type of science that I am is that materials are the same in everything. And what we tend to find, I look to the aerospace industry for incentive and what are they doing first, because they're the big boys that are sort of creating these incredible spacecrafts, and they have to go through lots of rigorous legislation and checks and validations and stuff. It's so huge crossover, which is exciting, because if we are talking about flying cars, then maybe we will see some of my work on a spaceship.
So I think I would absolutely to jump at the chance to get into outer space. If somebody offered me to get into a submarine to go to the bottom of the ocean, I might do it, but it might be a little more hesitant, but definitely into outer space. And speaking of outer space, I think that leads us perfectly into the challenge that you have set for all of our brilliant students out there who are taking part in this. And what have you got for us, Ella?
So I'm really excited to announce my invention challenge, and what I would like you guys to do is see if you can design a way to travel through space. So get into the head of what a materials scientist or McLaren engineer would think, and we want you to design a craft or device that will allow travel across the vast distances of our solar systems safely, comfortably, stylishly, and most importantly, only using sustainable energy in the most environmentally friendly way possible. So think about the creation of the product, how it's going to be tested, where will the materials that you make this craft come from, what infrastructure would it require? We talked about those charging points, or how is it going to refuel, where's it going to get the sustainable energy from, and what will make your invention better than anything else out there. So I want to think about what you're transporting across space. If it's for one person, is it for a pet, maybe your whole family or even your whole class? And your design should be presented in sketches, drawings, notes, anything that can allow us to understand what that design is. As well as a sketch, you can create a prototype model that you've designed or created yourself that can give you a better understanding of what your idea really looks like and how it may work. I find that building a prototype is really useful, but it does involve a little bit more time and effort from you, so it may be part of the fun. So we do have little inventors working with us, and they can really give you some help. I want to leave you with 3 tips that I would consider when jumping into this challenge, and these are based on my experience as a McLaren engineer and how I roll out my ideas. So the first one would be, think of your audience. Who's going to drive this thing? Where are they going to want to go? What are they going to use it for? Second thing, test it. So the scientist in me really wants to validate everything and make sure it all works. We talked about prototypes. This is simply a model that you make before you finalize your entire thing. So test it out. How is it going to work? And the third bit, what does it look like? Of course, at the end of the day, if you're a McLaren engineer, you're going to be wondering how it appears to the customer. Do you want customers to buy your spacecraft? Then you've got to make it look appealing. So consider the design and the final look of your design piece as well.
That is brilliant. Thank you, Ella. What a great challenge, you know. So yeah, I'm going to get stuck in with my kids. I'll make it look good, and they'll probably figure out how it actually works. But if you're looking for some ideas around this, then take a look at the video that's been made with a little help from our friends Little Inventors for some more ideas and inspiration. Ella, thank you so much. What a pleasure it has been. And I'm going to think differently about driving our electric car around now, and just all of the thought that goes into making something like that. So I wish you well, and thanks for joining us.
Thank you, Oliver. It's been really, really fun.